Okay, let's take a look at example 2. We have ABCD is a trapezium and BA is parallel to CD. So you see if there's a parallel lines and you can see there's a vertically opposite angle, this is the shape of a butterfly that we have. So we know that this triangle AXB will be similar to triangle CXD. Okay, so these two triangles are similar. So if they're similar, we can say that the ratio of the corresponding sides will be equal. Okay, so the ratio of the corresponding sides will be equal. Next, what we have to do is to fill in any information that we know. So AB is the one that we need to find. CD is 16. XB is 15. And XD is 12. So if we simplify the equation, we get AB is equals to 15 multiplied by 16 divided by 12. Our answer will be 20 cm. So this is part A. Okay, for the next part, part B, now we are given that the length of AC, which is this whole length over here, is 18 cm. We need to find what's the length of XC. So you see that since AC is across two similar triangles, what we need to do is label XC, the unknown, as X. So if XC is X, AX will be 15 minus XCM. So with this, we can fill it into our ratio. Since these two triangles are similar, the ratio of the sides will be similar as well. So we fill it in, 15 minus X over X equals to XB or AB 20 divided by 16, which we found just now, equals to XB, which is 15 divided by 12. So what we need to do now is to simplify the equation. What I do is I will take this and this, because this over here, 15 over 12, is a given value, whereas 20 is my calculated value. So if you can avoid using any calculated values, you should avoid. So now if I simplify my equation, I will cross multiply and I will get this. Okay, so when you're done, you'll get your value of X to be 8 cm. So to answer the question, find the length of CX, you will write, therefore CX or XC equals to 8 cm. Okay, let's take a look at part C, part 1. Find the ratio of the area of BXC over here to the ratio of the area of AXD, which is over here. So what I'll do, I'll put two ticks to identify which two triangles that we are using. So the first question to ask, is these two triangles similar? Is the two sides over here parallel? They are not, right? So if they are not, means that these two triangles are not similar. So the first ratio that we learn using ratio of similar triangles cannot be used. Next, does these two triangles have the same height in any way? Not exactly, because we realize that the height of this triangle would be either here, here, or here. And the common height for this triangle would be here, here, or here. So we are left with the last one, which is ratio of areas of unrelated triangles linked by a common triangle. Okay, so what I'll do now, I'll label this as triangle 1, which should always be the numerator of what we want to find. And next, this triangle will be triangle 3, which is the denominator of the ratio that we want to find. So looking at this, the common triangle will actually be this over here, which is CXD. So this will be my triangle 2. So if you recall how they are related, if my triangle 1 is to triangle 3, will be equal to triangle 1 is to triangle 2. So now we are comparing 1 and 2 only, multiplied by triangle 2 as compared to triangle 3. So this method actually makes use of 1 compared to 2, and next 2, these two 3, and we multiply together to see how 1 is compared to triangle 3. Okay, so we will get something like this. Area of BXC is my triangle 1. Area of CXD is my triangle 2. Multiply by area of CXD, which is my triangle 2, over area of AXD, which is my triangle 3. So what we have to do now is to do part by part. So we do the first part first, where we compare triangle 1 to triangle 2. Okay, if we look at BXC and we look at CXD, are these two triangles similar? Okay, think about it. There is no common angles between this triangle and this triangle. So these two triangles are not similar. So we can't use the ratio of areas of similar triangles. So the next we have learned is the common height. Does this triangle and this triangle have any common height? If you realize, if I draw a height over here, and label it as h, can you actually see that this height here can be used to find out what is the area of triangle BXC, given that 15 as the base, as well as this height over here can be used to find out what is the area of CXD, given 12 as the base. If you can't, it will be good for you to rotate your paper upside down. So what we will have here will be area of BXC will be half times base 15 multiplied by height over half times 12 multiplied by height. Okay, so we are done with comparing triangles 1 and 2. So now we look at triangle 2 and triangle 3. So you can see that this is similar to what we have done initially. They are actually linked by a common height. So the common height will be over here, and I'll label this as capital H, so to differentiate between the two heights. You can label it as any other alphabet as well. So comparing triangle 2 and 3, we have half times base. Now my base is actually CX over here. So if my base is over here, my height must be the perpendicular height. So the value of CX, which we have found initially, is 8. Multiplied by height, 2 half multiplied by the base. My base is now AX. So with AX as my base and H as my height, I can find the area of AXD. So the value of AX will be 18 minus 8 will be 10 multiplied by my height. Okay, next thing will be the simpler one. We just need to simplify our equation. So all the common terms we will actually cancel away, and we simplify the remaining fraction into simplest form. So 15 and 12, we can have it to be 5 and 4. 8 and 10, we can have it as 4 and 5. So this 4 and this 4 will simplify, this 5 and this 5 will simplify. Eventually, our ratio or answer will be 1. Okay, this is a slightly longer example, but the approach to solving this kind of questions is to first ask yourself, are these two triangles similar triangles? If they are not, move on to the next approach to find out if there's any common height. If there's no common height, next thing you can do is to find a common triangle that links triangle 1 to triangle 3. So you can do it by parts by comparing triangle 1 and 2 first, followed by comparing triangle 2 and 3. And what you can do is to multiply them together to find how two unrelated triangles can be linked together. Okay, next we come to C part 2. We need to find the ratio of area of triangle BXC to the area of ABCD, which is the whole trapezium. So first, ask yourself, is this triangle BXC a similar triangle to ABCD? No, right? Because one is a triangle and one is a trapezium. Next thing you ask yourself, does this triangle BXC and ABCD have the common height? You realize that there isn't any common height as well. So the last one you can do is they are unrelated. So you need to find a common triangle that links both of them up. So the first thing you do is to label my numerator, which is BXC, as triangle 1, and ABCD, which is the whole trapezium, as triangle or figure 3. So I'll label it in the center since it refers to the whole figure. So just to recall, 1 over 3 or 1 is to 3 equals to 1 is to 2 multiplied by 2 is to 3. So we compare between 1 and 2 first, and subsequently we compare it between 2 and 3. Okay, so now what will you think my triangle 2 will be? So I give you a hint. This would be slightly difficult. Okay, my triangle 2 will actually be B, C, D. So this triangle that I highlighted in blue will actually be my triangle 2. Okay, why did I choose this as my triangle 2? If you realize how 1 and 2 are related would be by a common height. And the common height will be this height over here. Next, how 2 and 3 will be related is actually by a common height as well. And this height, if I will draw in a different color, will be this height over here, which is my height of my trapezium as well as the height of my triangle 2. So if I extend out, you realize that the height is also this height over here, which I label as capital H. Okay, so what I did, I just wrote the ratio out. Area of triangle BXC, which is my triangle 1, to the ratio of my triangle BCD, which is my bigger triangle. So if you write the ratio out, it will be half multiplied by base will be 15 multiplied by height h over half times base, and now this base will be actually 15 plus 12 because I'm finding the area of my whole triangle. So my base will be 27 multiplied by h. So I'm done with my comparison of triangle 1 and 2. So now let's take a look, how do I compare between triangle 2 and 3. Okay, between 2 and 3 over here, now my base is not BD anymore, but rather it is CD. Because with this as my base, I can use this light blue or capital H as my height to find the area of the triangle. So this is like using two different methods of finding the area of the same triangle. So my base would be 16 multiplied by capital H because of different height. And next, how to find the area of the area of trapezium, will be half times height multiplied by the sum of the parallel sides. So AB as found in part A is actually 20 cm. So next thing we can do, simplify our equation by removing the common terms, and we will have 15 over 27 multiplied by 16 over 36. So if you simplify this, our final answer will be 20 over 81. So this is the answer given at the bottom. So the difficulty of this kind of question, finding the ratio of area, is to practice more to identify the different kinds of triangles that you may see. So if more practice, you can easily identify whether the triangles are similar or whether they're the common height or they are totally unrelated at all. So at least you know which formula or which ratio that you should use to approach this kind of questions. Okay, so with that, give your mind a break before you actually try out the examples on your own. Okay, homework 2 is actually not easy. It actually needs you to really focus and understand which method that you are going to use. So have fun!